discuss structure of oxides of nitrogen, structure of oxoacids of nitrogen, preparation of oxoacids of nitrogen. These are the three important points. How to discuss three important topics. First one, structure of oxides of nitrogen, structure of oxoacids of nitrogen, preparation of oxoacids of nitrogen. Already we learned the structure thoroughly in the inorganic chemistry. Am I right? Every structures and electron dot structure, how the electron occupation, everything we learned. Today also we can be learned. First you have to complete preparation of oxoacids of nitrogen. After that we can be discussed about the structure of some inorganic compounds. Okay. First one, preparation of oxoacids of nitrogen. They are having 5 nitrogen compounds. One is about that hyponitrous acid, second one nitrous acid, third one pernitrous acid, fourth one nitric acid, fifth one pernitric acid. Dear children, here what is the formula of each nitrogen compounds? Hyponitrous acid, what is the formula here? H2N2O2. What is the formula of nitrous acid? HNO2. What is the formula of pernitrous acid? HOONO. What is the formula of nitric acid? HNO3. What is the formula of pernitric acid? HNO4. These are some inorganic nitrogen compounds. Am I right? So, here if you have to learn what is the difference in hyponitrous acid and nitrous acid. I am telling about that, about the formula, based on the formula. What are the differences between nitrous acid and hyponitrous acid? Please check the element. Hyponitrous acid having 2 hydrogen, 2 nitrogen, 2 oxygen. What about the nitrous acid having 1 hydrogen, 1 nitrogen and 2 oxygen? Am I right? So here having NH is different. Am I right? That is HN. There have 2 hydrogen, here having 1 hydrogen, they are having 2 nitrogen, here having 1 nitrogen, they are having 2 oxygen, here having 2 oxygen. Am I right? So one small difference is about that NH is not having in a nitrous acid. What about that? Next one, pernitrous acid. What is the differences between nitrous acid and pernitrous acid? Nitrous acid, all of you know that the formula is HNO2. Pernitrous acid formula HOONO. HOONO. Am I right? So one of an oxygen is an excess. Am I right? Next about nitric acid and also about the pernitric acid. What is the difference here means? Nitric acid formula HNO3, pernitric acid formula HNO4. What is the difference there? Excess one of an oxygen having in where? Pernitric acid. Next you have to learn about that. Oxidation state of hyponitrous acid. Oxidation state. Already we learned thoroughly. Hyponitrous acid formula. Everyone know that. You know what is the formula? H2N2O2. H2N2O2. Am I right? So each hydrogen, that is alkali metal. Alkali metal, that is a hydrogen, sodium, potassium. These are all having +1. Don't forget that. What is the value here? +1. So 2 hydrogen is there. 2 into +1 plus. Here having 2 nitrogen. Nitrogen is taken as a X. So make it as 2X plus 1 oxygen having the charge is about the -2. Here having 2 oxygen, 2 into -2 is equal to 0. So how will you write the formula here? 2 into +1 plus 2x plus 2 into -2 equal to 0. It can be written as 2 plus 2x minus 4 is equal to 0. 2x is equal to 4 minus 2. 2x is equal to 2. X is equal to 2 by 2. That is equal to 1. So what is the oxidation state here? +1 is the oxidation state. Next about how can you prepare hyponitrous acid? How can you prepare hyponitrous acid? Here we have to take silver hyponitrate. Silver hyponitrate. What is the formula of silver hyponitrate formula? Ag2N2O2. What is the formula? Tell me. Ag2N2O2. This one reacts with hydrochloric acid. We get the silver combines with the chlorine to form AgCl. So our expected product is, that means H2N2O2. Here having hydrogen, H2N2O2. Am I right? So how can you balance the equation? Reactant side having how much chlorine is there, how much silver is there? 2 silver, so make it the product side 2 silver. Product side having how much chlorine is there? 2 chlorine, the reactant side also make it 2. So 2 hydrogen, now the reaction is balanced. Am I right? Now the equation is balanced. What about that? The next one, nitrous acid. Nitrous acid, what is the oxidation state of nitrous acid? All of you know that one. Hydrogen is about the +1, nitrogen is taken as X, oxygen is -2 into 2. Am I right? So +1 plus X minus 2 into -2 is equal to 0. +1 plus X minus 4 is equal to 0. X is equal to 4 minus 1 is equal to X is equal to +3 oxidation state. Am I right? So how will you write the equation? Barium nitrite. What is the formula of barium nitrite? BaNO2 twice plus sulfuric acid. What is the formula of sulfuric acid? H2SO4. Here hydrogen combines with nitrite NO2. Hydrogen combines with nitrite NO2. We get 2 molecules of, here having nitrite having 2 molecules of what? HNO3. That is, we can be written as H2, that is HNO2 plus barium combines with the sulfate to form barium sulfate. Barium sulfate. How to balance the equation? 2 nitrate, so make it 2 nitrate. Hydrogen also 2. Now the equation is balanced. Next about pernitrous acid. What is the difference in the formula? Pernitrous acid. They are having extra one more oxygen is there as we are comparing nitrous acid, because nitrous acid having 2 oxygen. Here having 3 oxygen, they are having 1 nitrogen, they are having 1 hydrogen, here having 1 nitrogen, 1 hydrogen. Next we can discuss about the pernitrous acid. Pernitrous acid. What is the formula pernitrous acid? HOONO. HOONO. Next you have to find out the oxidation state of pernitrous acid. So here having the formula is HOONO. 1 hydrogen atom is +1 and the nitrogen is taken as a X. Next, 3 oxygen having 3 into -2 equal to 0. +1 plus X minus 6 is equal to 0. X is equal to 6 minus 1. X is equal to +5 oxidation state. What is the oxidation state here? +5 oxidation state. Next one, we have to write the equation. We are taking hydrogen peroxide. Hydrogen peroxide. Can you understand me? Hydrogen peroxide. What is the formula of hydrogen peroxide? H2O2. This one reacts with the nitrous acid. What is the formula here? HNO2. HNO2. Otherwise, we can be written as ONOH. Am I right? ONOH. Okay. Here, in this hydrogen peroxide, one of an oxygen is attached to OH. One of an oxygen is attachment to OH. So, what is the expected product? ONOOH. ONOOH. Otherwise, we can be written as HOONO. HOONO. This is the formula of pernitrous acid, and also we get hydrogen water molecule H2O. Am I right? Now the equation is balanced. Next about nitric acid. What is the formula of nitric acid? All of you know that one. HNO3 is the formula for nitric acid. Here the have to find the oxidation state of nitric acid. H means we can know that one +1 plus X for nitrogen plus 3 oxygen having 3 into 1 oxygen is -2. 3 into -2 is equal to 0. Am I right? So X is equal to 6 minus 1. So X is equal to +5 oxidation state. Here nitric acid preparation, we have 4 steps of reaction. 4 steps of reaction. One is about that ammonia is converted into NO. Second one is NO is converted into nitrogen dioxide. Next, nitrogen dioxide is converted into nitrogen tetroxide. Nitrogen tetroxide is converted into nitric acid. Like that, 4 reaction we have. How much reaction? 4 reaction. What is about the first one? Ammonia. Ammonia and reacts with water. We know that one ammonia is prepared from Habe's process. Here we are taking N2, that is a nitrogen gas, plus 3H2, that is a hydrogen gas, gives the presence of ion, we get ammonia. Am I right? NH3. You have to balance the equation. N2, 3H2 means 2NH3. 2 ammonia is there. Here using one of the catalysts is called as an ion act as a catalyst, and also we are using promoters, substance which enhance the speed of the reaction. Okay, promoters we are using speed up the reactions. Promoters we are using, that is called as a molybdenum MO. Molybdenum is what? MO. It is not a catalyst which promote the activity of the catalyst. Okay, that we can be discussed later. Okay, so in the Haber's process we are using nitrogen plus hydrogen gives ammonia. And also this ammonia I am taking, this ammonia plus oxygen molecule. Oxygen molecule is they are having excess in air. Am I right? Air having 78% of nitrogen and 21% of oxygen. Am I right? So that air I am taking. This ammonia and reacts with the air to form NO, and also hydrogen combines with the oxygen, we get water molecule. Hydrogen combines with oxygen, we get what? Water molecules. Am I right? How can you balance the equation? Here NO, the product side NO, we have to make it 4. Make it 4. So we get 4 NO. Am I right? 4 NO. So the reactant side we have 4 ammonia. So make it 4 there. So now how much hydrogen is there? 4 into 3 is equal to 12. So water molecules also make it 6 there. 6 into 2 is equal to 12. Am I right? 6 into 2 is equal to 12. So here how can you balance the oxygen? 4 plus 6 is equal to 10. So make it 5 into 2 is equal to 10. So that equation is balanced. Second step, NO on reacts with oxygen. NO on reacts with oxygen, we get nitrogen dioxide. Nitrogen dioxide. How can you balance the equation? Here the product side make it 2. So the reaction side also make it 2. Now the reaction is balanced. Next about NO2 is converted into N2O4. NO2 is converted into what? N2O4. So how much nitrogen is there in the product side? 2. So make it 2 on the reactant side. Now the reaction is balanced. Next one, nitrogen tetroxide. What is the formula here? N2O4. This N2O4 on reacting with the water and the presence of oxygen, we get HNO3. That is about the nitric acid, HNO3. So how to balance the equation? In the reactant side, how much water molecules there? 2 water molecules. So make it 2 here. So we get 4 hydrogen. So the product side make it 4 hydrogen. Now the reactant side also make it 4. So 2 into 2N2O4. Now the equation is balanced. The last one is about that pernitric acid. Pernitric acid, that is adding of 1 oxygen to nitric acid, and we get pernitric acid. What is the formula? HNO4. Okay, the last preparation, pernitric acid. What is the formula of pernitric acid? HNO4. HNO4. Now you have to find out the oxidation state of HNO4. Hydrogen is taken as +1, nitrogen is taken as X, and oxygen having 4. 4 into -2 is equal to 0. So +1 plus X minus 8 is equal to 0. X is equal to 8 minus 1. X is equal to +7 oxidation state. Next about that, preparation of pernitric acid. In the pernitrous acid, we take nitrous acid and also hydrogen peroxide. Am I right? Hydrogen peroxide and nitrous acid we take. Am I right? Here also same like that. We are taking hydrogen peroxide. What is the formula of hydrogen peroxide? H2O2 plus nitrogen pentoxide. Nitrogen pentoxide, that is N2O5, gives pernitric acid formula. HNO4 plus nitric acid formula HNO3. So which are the possible product here? HNO3 plus HNO4. Am I right? HNO4 plus HNO3. Am I right? This HNO4 is called as pernitric acid. Again we can be written as pernitric acid, that is HNO4 can be written as NO2OOH. NO2OOH. This is about the preparation. Let us learn about that. The structure of nitrogen compounds, structure of oxides of nitrogen compounds, otherwise oxides of nitrogen. Dear children, the structure, whenever we are drawing the structure, I think that we have a lot of structures. That is, I think that more than 6 having here, more than 5. So first one, nitrous acid. How will you write nitrous acid? What is the formula? N2O. Okay, N2O. Here having 3 element. Am I right? 3 element. We have to make it 3 element. There is 2 nitrogen and 1 oxygen. So before that, we have to write the atomic number of nitrogen is equal to 7. First shell we can be accommodate 2 electrons, second shell 5 electron. So 2 nitrogen, that means outermost shell having 5 into 2 is equal to 10 electron. Am I right? 10 electron. 1 oxygen, that's atomic number is 8. First shell we can be accommodate 2 electron, second shell 6 electron. So how much number of electron present in the outermost shell means 5 plus 5, 10 for nitrogen and 1, that's 6 for oxygen. So total we have 16 electrons. How much electron? 16 electrons. Am I right? As per the octet rule, octet need how much electron for the for needing the dot electron structure? That is 1 element means except the hydrogen, others are everything. How much? 8 electrons. Am I right? So here having 3 element. 3 into 18 is equal to 24. That is a must we needed. But we have how much having? 16 only having. Am I right? So 24 minus 16. 24 minus 16 is equal to 8 electrons. Am I right? So 8 electrons. Here 8 electrons means this is a shortage of electrons. This shortage of electrons, first I am bonding here. Okay, bonding these 3 elements. Am I right? One bond means 2 electron needed. Am I right? Here I am making, for example, nitrogen and oxygen. I am making 1 bond. Okay, we know that on nitrogen is a triple bond. Am I right? Nitrogen is a triple bond. We know that one. So if I am making 1 bond means we need how much electrons? We need 2 electrons. So I make here 4 bond. 4 bond means how much electron need? 4 into 2 is equal to 8 electrons is over. So as per the outermost shell having 16 electron, this 16 electron, 8 electron is over. Am I right? Then how much electron is remaining? The remaining electron is 8. Am I right? Out of 16, 8 over. 8 goes to the bond. Am I right? Out of 16, 8 over. That is goes to the bond. Am I right? Next we have the remaining 8 electrons. So having only single bond. Single bond having means 6 electron. We can be accommodate how much electron? 6 electron. That is about that 1, 2, 3, 4, 5, 6. Here already 2 having, so 8 electrons. Am I right? So octet rule. Am I right? Following the octet rule. Next. Again we have 2 more electrons. That 2 more electrons we can be accommodated the nitrogen. Okay. Can you understand, my dear children? First you have to find out valence electron. Valence electron of 1 nitrogen is how much? 5. 2 nitrogen is 10. So oxygen is 6. So 10 plus 6, 16 electron we having. But we needed 24 electrons. Okay. Because 1 electron, suppose 1 element. For example, I am taking 1 element. 1 element is surrounded by 8 electrons. As per 8 electrons, here having 3 elements. 3 into 8 is equal to 24. But here having only 16 electrons. So 8 electrons are the shortage. Anyhow, one bond means 2 electrons. So I am divide by 2. Divide by 2 means 8. Divide by 2 means 4. So 4 bond is sufficient. Am I right? So for joining here 4 bond. Here 1 bond. It's a single nitrogen oxygen having single bond. Next again I am making 3. So our bond is over. So 4 bond means 8 electron needed. Out of 16, 8 is over. What is about the 8 electrons remaining? First the single bond having I am giving 6 electron and also make it 2. Am I right? Next, this is about the first step. Second step, there is one possibility for, if I am this bond is shifting here means, second possibility. So nitrogen double bond, nitrogen oxygen is also double bond. Am I right? So now how can you find the charge? Okay, that also I told you about the how to find the charge. Okay, so suppose I am breaking here, I am breaking nitrogen triple bond, I am breaking here. Suppose breaking means 1, 2, 3, 4 electron only having. I told that nitrogen having 5 electron in the outermost shell. Yes or no? 5 electron in the outermost shell. But here having only 4. 4 means it lost 1 electron. It loses 1 electron. Am I right? It loses 1 electron. So we are giving plus charge. Here we can be finding, suppose I am breaking here means now we can be count 1, 2, 3, 4, 5, 6. Here also having 1 electrons. Am I right? Because here having 1 bond. So here having 1 bond. Breaking, the next oxygen having 7 electron. But outermost shell oxygen having 6 electron because the atomic number is 8. First shell we can be accommodate 2 electrons. Second shell we can be accommodate how much electron? 6 electron. Am I right? But when we are counting here 7 electron coming, that is additional electron having oxygen, so negative charge. Can you understand, my dear children? Second step, we are going to the second reaction. Nitrogen double bond, nitrogen oxygen double bond. Okay, yes or no? The same process we are doing. 3 element means 24 electrons. Am I right? 3 element means 24 electrons. But here the possibility how much electron having? Well, is 16. Am I right? Out of 16, what is the remaining? 24 minus 16, the remaining means 8. 8 means we are dividing by 4. 4 divided by 2 means we get the 4 answer. Am I right? 8 divided by 2 means we get 4 answer. 4. So 4 means here having 1, 2, 3, 4 bond. Am I right? 1, 2, 3, 4 bonds. Okay, 4 bonds. Next, out of 16, 8 is next remaining having 4 electrons. So this remaining 4 electrons we can be accommodated to the oxygen. Double bond having oxygen, single bond having means we can be accommodated 6 electron. Double bond having means 4 electron. Am I right? 1, 2, 3, 4. Next goes to the nitrogen. Here we can be give 1, 2, 3, 4, remaining 4 electrons. Okay, this 4 plus 1, 2, 3, 4, 5, 6, 7, 8. This is also attained inert gas configuration. Next about this nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. This also attained inert gas configuration. Now we can be find the charge. Okay, how will you find out the charge of this here? Here breaking here means 1, 2, 3, 4, 5, 6. Am I right? So oxygen you have 6 electron. Outermost you have 6 electron only. So no problem. Here, this nitrogen. 1, 2, 3, 4. Am I right? 1, 2, 3. Because double bond. 1, 2. Here also I am breaking. 1, 2, 4 electron. But nitrogen must contain 5 electron. But this having only 4 electron. Loss of electron. So I am giving plus charge. Am I right? Plus charge. Next here, when I am counting this nitrogen. 1, 2, 3, 4, 5, 6. This bond break means 5, 6. Extra electron having so minus charge. Like that you have to such a way you have to practice. Am I right? So next one, you have to do it. Second one is also we can be easily do the second one. Third one. I'm going to third one. N2O3. Okay. N2O3. What's the name of the compound? Dinitrogen trioxide. This also you have to make it such a way like that. 2 nitrogen. First you have to use the 2 nitrogen. Okay. Next we can be accommodate 3 oxygen atom. 3 oxygen atom. One is in the upper part of the nitrogen. Second oxygen is go to the next nitrogen upper part. Next oxygen goes to the below part of the second nitrogen. Am I right? This way I am trying like that. Next we can do find out the outermost electrons. Am I right? One nitrogen atom is 5. Outermost having 5 electron. Second nitrogen having 5. So 5 plus 5, 10. Am I right? 10 electron. One oxygen atom 6. 3 oxygen atom is 18. Am I right? 6 3s are 18. Am I right? So 18 plus 10 is about the 28 electrons in the outermost shell. Yes or no? How much electrons having? 28. But as per inert gas configuration, one element means 8 electrons. Here having 1, 2, 3, 4, 5 elements. So 5 into 8 is equal to 40 electrons is needed. Am I right? But we have how much electron? 28 electrons. Am I right? Yes or no? So when we are subtracting this one, 12 electron is shortage. The 12 electron I am dividing by 2 because one bond means 2 electrons. Am I right? Dividing by 2 means 6 2s are 12. So 6 is, we get a 6. We have to make 6 bond. Am I right? 6 bond. Yes or no? So first I am giving oxygen nitrogen bond 1, nitrogen bond 1 2, nitrogen oxygen having 3, nitrogen other oxygen having 4. Am I right? Again we have 2 more bond. Am I right? So I am making here 1, below oxygen 1, and the first nitrogen I am giving 1 oxygen. So 6 bond is over. Am I right? Yes or no? Next. I told that we have 28 electron. Out of the 28 electron, 12 is over. Am I right? 12 electron. That means I am bond making. So 12 is over. What is the remaining? 16. Am I right? 16 electrons having. So the previous explain I told you that if they are having single bond means we can give 6 electron. Double bond having means we can give 4 electrons. Am I right? Suppose triple bond means we are giving 2 electrons. Don't forget that. They are having a single bond means 6 electron. Double bond means 4 electron. Triple bond means 2 electron. So first I am starting here single bond of oxygen. Single bond means how much electron? 6 electron. Am I right? 1 2 3 4 5 6. So 16 out of 6 over. Remaining 10. Am I right? Here I am in double bond. So 1 2 3 4. Am I right? So again 4 over. So next remaining. Here I am in double bond. 1 2 3 4. 4 over. Remaining how much? 2. Now please count that one. 6 plus 4 10. 10 plus 4 14. 14 plus 2 16. 16 over. Okay. Now we can find the charge. How will you find the charge? I told that first the valence electron. You have to find the charge means a simple method. You cannot do all the method. Okay, first we have to find out the simple method. Okay, charge. Suppose I am breaking here. One compound have means any one positive and one negative. Am I right? One positive charge and one negative charge. Suppose I am first breaking here means first breaking. This oxygen having 1, 2, 3, 4, 5, 6 electron. Am I right? So no charge. Okay. Correct electrons. Then below nitrogen. Here 1, 2, 3, 4, 5. Here also having no charge. Okay. Equal correct electrons. When I am comparing this NOO. Am I right? Here first upper part. 1, 2, 3, 4, 5, 6. Here some breaking here means 7 electrons. So make it minus. Next about the nitrogen. Here breaking 1. Here also breaking 2, 3. Here also breaking 4. Here loss of 1 electron. So make it plus. So, okay. So this nitrogen is having plus. The above oxygen having minus. Come to the second one. Same like we can do this one. Same. The second nitrogen, upper having single oxygen, below having double oxygen, double bond oxygen. So I am interchanging. Am I right? So upper same I am giving a double bond with oxygen, below a single bond with oxygen. Am I right? The same we have to do it. So the nitrogen, I told that is we have to write nitrogen, double bond oxygen, single bond nitrogen. Next, upper side double bond oxygen, below side single bond oxygen. So how much electrons needed? How much element having? 1, 2, 3, 4. 1, 2, 3, 4, 5 element having. One element need 8 electrons. 8 5s are 40 electrons is needed. But how to find out the outermost? Am I right? Outermost electron present in each element. How can you find out means? Nitrogen, 2 nitrogen having, so 1 nitrogen is 5, 5 plus 5, 10. 3 oxygen having, 6 into 3 is equal to 18. 10 plus 18 is equal to 28. So we get 28 having, the total 40 minus 28 is equal to, what's the remaining? Remaining 12, am I right? 12 having. If I am making bond, 12 divided by 2 means we get 6, am I right? So 6. So 6 bond we have to make it here. 1, 2, 3, 4, 5, 6. That also correct. Then about they are having single bond. Don't forget that out of 28, 12 minus means what is the remaining? 16 is the remaining. So 16, a single bond have means 6 electron we can give. So 6 here also 2 means 8 electrons is over. Double bond having means 4 electrons. Okay, here also double bond having means 4 electrons. Here remaining 2 more having we can give the nitrogen. Then we can find the charge. What is about the charge? We are dividing here. This oxygen having 1, 2, 3, 4, 5, 6. 6 electron. This nitrogen 1, 2, 3, 4, 5. There is no charge. What about this oxygen below oxygen? 1, 2, 3, 4, 5, 6. Here also one having 7. So additional electron having minus charge. What about this nitrogen? 1, 2, 3, 4. 4 only having. So loss of electron. So plus. Okay, this is about a structure. Okay, my dear children. This is, I think, that about the first or second class of this year. Already I gave the dot electron dot structure. You have to make practice this one. Okay. Remaining 3 have to make practice. Structure. Next one. Structure of oxoacids of nitrogen. Oxoacids of nitrogen. Okay. That means oxoacids of nitrogen means each compound having hydrogen. Am I right? Yes or no? Oxides of nitrogen, there is no hydrogen. There is only nitrogen and oxygen. Oxoacid, acid means that must contain hydrogen. Okay, hydrogen, H plus, that is must contain. So here, oxoacids of nitrogen means it must contain what? Hydrogen atom. Am I right? So here also having more than 5 compounds. First one is about that hyponitrous acid. Second one hydronitrous acid. Third one nitrous acid. Fourth one pernitrous acid. Fifth one nitric acid. Sixth one pernitric acid. Like that you have to have. Am I right? So what is the formula of hyponitrous acid? H2N2O2. What's the formula of hyponitrous acid? H2N2O2. What is about the hydronitrous acid? Again we can add 2 more hydrogen. So we get H4N2O4. That means we are adding H2O2 adding. Am I right? H2O2 adding. So what is the previous one? Hyponitrous acid. H2N2O2. H2N2O2. Hydronitrous acid formula H4N2O4. Am I right? Next one. Nitrous acid formula HNO2. Am I right? Nitrous acid formula HNO2. Per nitrous acid formula HOONO. Nitric acid formula HNO3. Per nitric acid formula HNO4. These are everything we learn. Okay. Just I am drawing one or two structure. Okay. If you have any doubt, please ask me. Okay, for filling the electrons. Okay, any doubt, whatever may be the doubt, you can be ask me. First, you have to draw the structure. Okay, draw the structure simply. Otherwise, in the textbook, having that structure is enough. Take return practice. First one I am writing hyponitrous acid, which are the element having 2 hydrogen, 2 nitrogen and 2 oxygen. First I am taking the nitrogen. All of you know that one nitrogen bond is triple bond, am I right? So one side one OH will be attached, next side is also one OH2 attached. So you must make it nitrogen, nitrogen, not triple bond, double bond. Nitrogen, nitrogen, double bond, am I right? So again, one side one OH, other side another one OH. So the structure is over. Next one, hydronitrous acid. Hydronitrous acid. How will you write? What is the formula here? H4N2O4. H4N2O4. First you have to draw nitrogen. How much nitrogen is there? 2 nitrogen. That 1 nitrogen. I am writing above 1 nitrogen. Am I right? Above 1 nitrogen. Next, how much hydrogen is there? 4 hydrogen. How much oxygen is there? 4 oxygen. Am I right? 4 hydrogen, 4 oxygen. So the 4 sides we have to accommodate. Am I right? So 1 nitrogen I am writing one side OH. Other side also 1 OH. Yes or no? Can you draw? Other one, other nitrogen, one side also 1 OH. Other side 1 OH. Now the structure is over. Okay? If you have any doubt means please ask me. Those who are need to draw the electron dot structure means you can do it, no problem. Otherwise simply the structure is enough. Okay. Next one, nitrous acid formula HNO2. Am I right? HNO2. How will you write HNO2? HNO2, how will you write? First you have to take a nitrogen. Nitrogen. Next, how much hydrogen is there? 1 hydrogen. How much oxygen is there? 2 oxygen. So one side, any one side you make it oxygen. Other side of nitrogen, other one more oxygen. Then join with one hydrogen. Okay, hydrogen. So now we give nitrogen oxygen bond is double bond. Next one, nitrogen oxygen with the hydrogen having single bond. Okay, this is over. Don't forget that. Then if you those who are need means you use the dot electron dot structure. Per nitric acid, what is the formula per nitric acid? HOONO. HOONO. So how much nitrogen is there? 1 nitrogen. So nitrogen, you have to draw nitrogen. Next one side oxygen. Other side another one oxygen. Join with another one oxygen. Join with another one hydrogen. So here having single bond, make it here double bond. Okay, now the structure is over. Those who are willing the electron dot structure, make it, otherwise leave it that one. Okay. Next is about that nitric acid. What is the formula of nitric acid? HNO3. This can be written as HNO3. We can be started with the nitrogen. Nitrogen. One side one oxygen. And above one oxygen. Next side one oxygen. Next side one hydrogen. So what is the formula? HNO3. HNO3. So there have one single bond. Make it a double bond here. Okay. And here also having one single bond. Here one minus charge. Here one plus charge. Okay. Next one. Per nitric acid. What is the formula? HNO4. So start with nitrogen. Upside one oxygen. Next left side one oxygen. Right side oxygen. Joined with other OH. Okay. So single bond having make it one minus. Here nitrogen having plus. Okay. Okay. So just to understand this concept, okay, if you have any doubt, please ask me, okay. Today assignment, page number 66, preparation of oxoacids of nitrogen, preparation. I think that 5 preparation, 1, 2, 3, 4, 5 preparation. Hyponitrous acid, nitrous acid, per nitrous acid, nitric acid and pernitric acid. Okay, that is a oxoacid. Oxo means, don't forget that, oxoacid. Oxoacid means, don't forget that, acid means it must contain what? Hydrogen. Don't forget that. Okay, please write this equation. Okay, equation is alone. Okay, that is a preparation of hyponitrous acid, preparation of nitrous acid, preparation of pernitrous acid, preparation of nitric acid, preparation of pernitric acid. Okay, please all of you write this assignment. Thank you all of you. Thank you. Have a nice day.